Very good morning. Welcome to my class in System Modeling and Simulation. Today we are going to discuss about the Discrete Event System Simulation. This is under model number 1, Introduction to Simulation part. So we'll discuss about the Discrete Event System Simulation. The model of a system in which state variable changes only at a discrete set of points in a time. We already discussed this. And these models are analyzed by numerical rather than by analytical methods, and these analytical methods employ the deductive reasoning of mathematics to solve the model. Example, differential calculus can be used to determine the minimum cost policy for some inventory models. So this we have already discussed. And numerical methods use computational procedures and are morons, which is generated based on the model assumptions and observations. These are collected to be analyzed and to estimate the true system performance measures. And real world simulation is so vast whose runs are conducted with the help of a computer, and this can be obtained by simulation manually, which is applicable for small. And now we will see the steps in simulation study. One is problem formulation and setting of objectives and overall project plan, model conceptualization, data collection, model translation, and verified validated experimental design, production runs and analysis, and more runs and documentation and reporting. Either we can say it is a testing part. So first of all, we need to understand the problem statement. So normally every problem, every statement is begins with a problem, and each and every problem phenomena will be given by the policymakers, so that the analyst makes sure that they have to correctly given all the requirements or resources to the particular design process. So afterwards the policymakers has to study the problem formulation, whatever needed, and after we can go for the overall project plan. So this is the main thing in the simulation study process, and afterwards we can go for the model conceptualization and data collection. So these two things will be simultaneously working with each other without affecting anything, and then afterwards we can go for the model translation, either one things to another things, how it is going to move everything, and verified validation process is must after collecting the datas and all, and then go for runs and or productions, and finally we'll go for testing. So this is the diagram. We can see the steps we can see in this simulation study. First thing is problem formulation. So in this problem formulation, first step is problem formulation. In this we'll see this problem formulation is nothing but we have to, once we can go for a new design process, we have to find out the problem statement or problem analysis or problem requirement, things. What are the problems which we can face in this study, everything we have to analyze, and afterwards we have to go for the overall project plan. So first of all, how to set up objectives first. So once we know the problems, then we can go for the objectives based on the new design process or actual design process what we are going to do. And overall project plan in the sense till testing, how our project is going to work it out. Work in process or gathering of information, organizational, and setting of objectives, everything will come under the overall project plan. And afterwards model conceptualization. So in this model conceptualization, we have to go through simultaneously these model conceptualization and data collection will simultaneously work and without affecting with each other. That is, model conceptualization is nothing but the abstract of the user experience, we can say, and what are the abstract we can get it from the previous existing system. So based on this we can go for model conceptualization and then data collection process and model translation. If we need to translate from one phenomena to another phenomena, we can easily translate based on the data collection part. Overall data collection, after gathering the information, then we can go for the translation part, and then afterwards we can go for the verified part. So verified part, in this verified part First, in this verified part, actually everything will be correctly procured or not, we have to check based on the analyst or any other policy makers. So here all the logically and informations, everything will be in correct mode or not, we have to check, so that our project will be properly it will work it off. And then we'll go for, after verification we can go for the validation process. In this validation process, the overall design process, we are going to compare our overall design process with the existing one. And we have to if any corrections is there, then we can rectify it based on the what if questions or any other concepts we can use. Based on that, we are going to validate the things. If it is not logically correct or syntactically correct, we have to rectify it from the verification part, and we can validate the things. And afterwards we can go for the experimental design. So this experimental design is a most significant one, most significant part in the simulation study. And after validation, from problem formulation till validation, what are the things we have gone through, so everything will be reached out to the experimental design. And afterwards we'll get the we'll get the more runs. If we don't want any more runs, then we directly go to the documentation part and reporting part and implementation part. If we need more runs, again we have to go to the experimental design part, and we have to process the previous steps as accordingly, and then we'll come back to this documentation part. So we'll see one by one. The problem formulation. So problem formulation, every study should begin with the statement of the problem. We already discussed this. If the statement is provided by the policy makers or those that have the problem, the analyst must ensure that the problem being described is clearly understood. If a problem statement is being developed by the analyst, it is important that the policy makers understand and agree with the formulation. So these formulation is a most important one before committing with the overall project plan or setting of objectives. This problem formulation is the important one, and setting of objectives and overall project plan. So here these objectives indicate the questions to be answered by the simulation. The overall project plan should include a statement of alternative systems to be considered, and the method for evaluating the effectiveness of these alternatives. So if we are going to if we are going to consider the effectiveness of the changes to the system, then we can go for the remaining process. And these two things, the model conceptualization and data collection, will work with each other. This model conceptualization is like we can say it as a user experience through abstract, and the construction of a model of a system is probably as much arts as science. It is best to start with a simple model and build towards a greater complexity. So this conceptualization will not affect this data collection process, and this data collection process is also not going to affect this model conceptualization process. These two things will work simultaneously and without affecting with each other. And data collection, this is the overall gathering of information from scratch, from problem formulation till the current process. There is a constant interplay between the construction of the model and collection of the needed input data. So as the complexity of the model changes, the required elements also change. So if any of the complexity of the model changes, then the required data elements should also change, so that we have to consider those data elements once again from the scratch. And now we'll see the model translation. Most of the real world problem result in model that requires a great deal of information storage and computation, so that the model must be entered into computer recognizable format. So if you use a term program, even though it is possible to accomplish the desired result in many instances with little or no actual coding, then we have to translate from one phenomena to another phenomena, or one format to another format, which is recognizable for our the new project. And then remaining things is verified, validation, experimental design, production runs and analysis, and more runs, documentation part, and implementation part. So after After all this process, we finally will go to the verified part. So we already discussed this verified part. So whether the policymakers or any analyst correctly procured the document, correctly given the data files, logically whether it is correct or not, we have to check. And afterwards, in validation part, we have to compare the two things from of the our new design process with the existing one, whether it is validated or not. And experimental design, after this validation process, we can go for this experimental design as accordingly, based on the given requirements or resources from right from the scratch, problem formulation. And then we'll go for the, after this experimental design everything is okay, then we can go for the production runs and analysis. And if we need more runs, then we can again go back to the experimental design. And after finishing the previous steps, and then again you will come back to this documentation part and reporting part, and then implementation part. Thank you.